All right, recording is starting. Good morning, everyone. Today is Monday, October the 18th. We are back from fall break. So today we are doing day 3 of ellipses. This is the bell work, but we don't have time to go through it. Today's kind of long, just like every lesson in Unit 3. If we have time, we'll come back to this problem. Feel free to pause the video and work on this yourself. But everyone should be all caught up by now. Everyone should have the quiz done for the circles by now. We are on ellipses day 3. So, I was absent 2 of the 3 days last week, and you were supposed to watch the recorded session that we did Friday the previous week and also Monday afternoon. Or you just read the module and that's how you learned it, and that's fine too. All right. All right, so we're going to be going from general to standard form of an ellipse, similar to day 3 of circles. Make sure you got your paper, pencil, Desmos, or GeoGebra if you want to. All right, this is from your previous ellipse lessons. I'm going to skip this, but this is just a copy paste of those slides just to show the 2 equations, whether it's horizontal or vertical, and then a diagram labeling all the parts. Just to quickly review this diagram, these points here and here, those are the minor vertice points. E sub 1 and E sub 3, those are your major vertices. Your major vertices. Capital C, that's your center. From the center to a major vertex, that is length of A, like labeled here. From the center to a minor vertex, that is a length of B. This is also called the semi-minor axis length. Going back to C to the major vertex, that's called the semi-major axis length. And then lastly, from the center to your focus point is a length of C. Also, if you remember from last week, from your focus, from this point to a minor vertex, what is that length? In chat, what is that length? From focus to a minor vertex. Yes, it is. Noah is correct. It is a length of A also. So from the center to a major vertex is length A, but also from a focus to a minor vertex is a length of A. That's from last week. Just another diagram kind of showing just that length of A. We also have this formula we did last week. Okay, so this is similar to circles. So this is our first example, going from general form to standard form. The only difference, so what is the difference here that you notice between this and the circle equations from general to standard? Yeah, so the coefficients of x squared and y squared may not be a 1. So like Noah pointed out, that the coefficient of this x squared is a 4. So maybe take mental note or write it down that on your test, I may not tell you if the equation is a circle, an ellipse, a hyperbola, or parabola. But there's things that we can look at to say, oh yeah, I know it's going to be a circle because of this. I know it'll be an ellipse because of this. If it was a circle, the coefficients of x squared and y squared would both be a 1. then you would know it's a circle. And both positive, of course. We know that this is an ellipse because one or both of the coefficients of x squared and y squared are not a 1. They're both positive, but at least one of them is not a 1. In this case, this is a 4. So this tells us that this is an ellipse and not a circle. Make sure you are able to recognize the differences and determine the conic type. Right. So what do you think our first step is? So think about circles. What would we do if it was circles? What would we do? Yeah, we would move that constant to the other side. What else would we do? Well, before you factor, so you are correct. We do want to move the constant to the other side, just like circles. What else do we want to do? Yeah, so Naomi says we want to put the x's and the y stuff together, and she is correct. So just like circles, when we went from general to standard, you want to move the constant to the other side. We also want to reorder the terms so you have the x stuff together, the y stuff together. We also want to. So I think when we did circles, I also left some space. But before I leave some space, somebody in chat said, Rachel said we want to factor it. So she was just premature in that decision. But yes, you do want to factor it once you order them like this. But when you factor it, you're essentially factoring by grouping. So you are just looking at the x stuff here. So looking at this 4x squared and the 64x, what can I factor number wise? So ignore the x's because yes, we could pull out an x, but that's not going to help us. Remember, we're trying to complete the square like we did with circles. So looking at just the numbers, what can we pull out? It looks like a lot of you are saying a 4, and you are all correct. We can pull out a 4. So with the x stuff, we GCF, greatest common factor of 4 out, and we get x squared plus 16x. And just like circles, we're going to leave a little blank. So because we're going to put a number here, of course, because we're going to complete the square. And to double check, we can kind of just distribute this 4 to verify. 4 times x squared is 4x squared, and 4 times 16 is, in fact, 64. So just a good way to kind of check the other direction to make sure that we didn't factor it wrong. Because if you factor it wrong, we're going to have problems later on. Well, the problem being the wrong answer. All right, now looking at the y squared and the y. Now, because there's a 1 in front, I don't have to factor anything out. So all I'm going to do is just write that again, and I'm just going to show the grouping. We really don't need to have the parentheses around it like I do. I'm just doing that just to be consistent. But you don't need these parentheses because we didn't actually pull anything out. Hopefully that makes sense. All right. And then, of course, on the other side, I don't know why I put a blue box because it doesn't change. Okay, next. Who can tell me whether on mic or in chat, how do I complete the square for this? Now, just ignore the 4 for right now. So given this piece in here, so think back to circles, how can I complete the square? Divide the middle term by 2 and then square it. Yes, you are correct. We're going to take that that b term, the b, remember this is like a squared plus b squared plus c, right? So we take b, which is 16, and we divide by 2, and then we square it. So we divide by 2, and then we square it. We get 64. So then what number goes right here? My pointer is 64. Yeah. And that's the whole point of complete the square. We determine what number goes there. Oh, I don't have a box there. Okay, maybe. Oh. Yeah, I see I did this a little different. All right, that's fine. It looks like I wrote more lines. So kind of going back to the beginning. So when we did circles, we combined these first 2 lines into one step. I might retype this for next year's class and combine this into one, because really we don't need to do 2 lines. We could have moved the constant over and reordered in the same step, right? So I kind of don't need this anyway. All right, next. So once we put a 64 here, what do I have to do next? So it looks like a few of you are saying add 64 to the other side. Anyone else agree? There's there's 10 of you in here. Do the other 9 or so, 8 or so agree with that? Are we adding 64 to the other side? Would I pause this long if you were correct? Rachel's thinking, I don't know, maybe. So let's think. Are we really adding 64 to the left side? Like we wrote 64 there, but are we really adding 64 there? So Noah says we're really adding 64 times 4. Oh, I see a lot of you in chat are it's like the light bulb is turning on. So we're not really adding 64. We're really adding 4 times 64. Ooh, see, I see a lot of you are seeing that, right? You're seeing we are really not adding 64. We are adding whatever 4 times 64 is. Yeah, a little tricky, right? 4 times 64. And what is 4 times 64? 256. So we're really adding 256 to both sides. Ooh. So that is the only, I guess, difference when after we divide by 2 and square it, put the number there. Do not forget that we are actually not adding this number. We're adding whatever this, this factor times that constant is. 4 times 64 is 256. That's the only difference between complete the square from general to standard form of ellipses versus circles. We did not have to worry about that. All right, going back to the second half of the problem. What number goes under this little blue box here? Yeah, 100, because we take the 20, we divide by 2, and then we square it. And that's how we get 100. So are we adding 100 to both sides in this case? Yes, we are, because I kind of, we really didn't have to group these. I didn't have to show the 1 in front, but I did just to kind of show it's consistent with the ellipses. But yeah, 1 times 100 is still 100. But again, you didn't have to write the parentheses. You didn't have to show that one or that one factor. It doesn't change anything. But yeah, so we are adding 100 to both sides. And then negative 292 plus 256 plus 100 should give us 64 on the right side. All right, and then on the left side, so x squared plus 16x plus 64, that factors to what? What does that trinomial factor into? X plus 8 quantity squared. Yep. So complete the square. The whole point of doing this is to get to this binomial squared. And we know this is an 8, well, two ways. Because 8 plus 8 is 16 and 8 times 8 is 64. But we also know it's an 8 because when you divided that 16 divided by 2, we got 8. That number is a number that will always go here, just like circles. And of course, don't forget your 4, your factor of 4. It just kind of carries down throughout, just like so. Y squared plus 20y plus 100, what does that become? Yep, y plus 10 quantity squared. And we know that's a 10 because, well, after you cut it in half, that number is what it's going to factor into. And again, you don't have to put the 1 here. I am just showing it just to be consistent with what we're doing with ellipses, but you don't have to have this. We could just put y, the quantity y plus 10 squared without having the 1 in front. All right. Now remember, we are going from general to standard. If this was a circle, we would be done at this step. But in your notes, you should be able to either remember or reference what the standard form looks like of an ellipse. So the standard form of an ellipse, what will it always equal? So standard form, what will it always equal? What number? It will always equal a 1, correct. And it doesn't in this case, so what do I have to do in this step, you think? How can I make it a 1? Divide everything by 64, and you are correct. So we will divide everything by 64, left side and right side. And I'm just showing my work to look like this. So divide everything by 64, left side, right side. And then we have to simplify. So let's do the right side first, right? 64 over 64, this will equal 1. And then back to my left side here. So we have 4 times this binomial squared over 64. So how can I reduce 4 over 64? So it looks like Rachel says it becomes 1 over 16, and she is correct. Becomes 1 over 16, and just like kind of up here, we don't need the 1. I have it there just so we can see it to maybe work with it. But in your final answer, do not put a 1 in front. It's not needed because 1 times anything is itself. So again, in your final answer, do not put a 1 here. If you put a 1 there in your final answer, I will mark it wrong on your TGA, and the module quiz test will also mark it wrong because it is not completely simplified, and you do not need a 1 here. To everyone that's here and listening, that should be very, very clear. However, when I say this and I emphasize this, people that are not here, because they don't watch the recordings, and they don't do a whole lot in this class in terms of spending time and practicing, those people are the ones that will make that mistake. So do not put a 1 in your final answer. It's not needed. Same thing over here. Does 1 over 64, does that reduce any further than what you see? No, it doesn't. In your final answer, should I put this 1 here? Yeah, absolutely not. Good. And then that is your final answer. So I'm going to run through this problem real quick again to kind of talk about what we did now that we've seen it step by step. What we're going to do is we are going to move the constant to the other side. We're also going to reorder to have the x stuff together, the y stuff together, and then there's your constant to the other side. All right, that's your first step right there. Next, you're going to look at the x grouping and you're going to GCF any constant that we can, and we can pull out a 4, which we did. So we pull out a 4 out of the x stuff and then leave a space because we're going to put a number here. Look at the y stuff. We're going to pull out a number if we can, which we can't, other than a 1, which I do show here. Leave a space, just we did the x's. Next, complete the square, just like circles. Take that middle term, divide by 2, and then square it. 64 is what we get, so that's what goes in the blank there. When you add 64, we can't just put it to one side. Remember, this is an equation is a balance beam. So whatever whatever weight, right, whatever weight or numbers we add to one side to keep the balance beam balanced, you must add the same weight to the other side. So we are not adding 64, we are adding 4 times 64, which is 256. So our equation is still balanced. Next, the y stuff, we take the 20, divide by 2, and square it, we get 100. So that's what number we are putting here. And 1 times 100 is, of course, 100. From here, we now go into the factored form. This trinomial becomes this binomial squared. This trinomial becomes this binomial squared. Don't forget the factors of that grouping goes out in front. Factor of that grouping goes out in front. So now we're to this step. Remember, this is an ellipse, not a circle. It has to equal 1. So we must divide, well, by this number here, 64, which we do in this step. From here, we reduce it. 64 over 64 becomes 1. 4 over 64 becomes 1 over 16. So that is the reduced fraction. 1 over 64 is already reduced, so we just write this binomial squared over 64, and then we are done. Every ellipse problem going from general to standard is done just like this, but of course we're going to have different numbers. Yeah, the nice thing about general to standard, it's every problem is done the same way. There's no like, well, in this case we must do this instead, or in this case do this instead. No, it's nothing like that. The steps will always be the same. All right, let's everyone try this one. Everyone try this one. All right, let me give you, let's do 3 minutes. Ready, go. All right, when you're done with this problem, give me a green check mark. When the majority of you are finished, I will go on. So I see 4 of you are tabbed out. So not sure why, but if you're tabbed out, I'm going to assume that you are not listening, and I will ignore your vote. Well, I will ignore your lack of a vote. How about that? Ooh, before I forget, why are you guys still working? Don't forget, today is the start of Raise My Grade for pre-calc. I will send an email after class at noon today. I meant to do it this morning, I forgot. But Raise My Grade, as you're, hopefully I'm not distracting you too much telling you this now, but Raise My Grade, it allows you to retake one of your unit tests, whether it's Unit 1, Unit 2, or even your midterm. In the past, nobody has actually retaken the midterm because the midterm was actually super easy. I made the midterm easy to help raise grades, and usually it did just that. So you took the midterm, most people did very well, and it raised your grade. And you're probably thinking, yeah, it actually did raise my grade because you did very well. And the people who do not do well on the midterm are the ones that, well, don't come to class, don't watch the recordings, don't practice in the modules, wait till the last moment to submit their test, etc., etc. Those are the ones that don't do so great and usually don't do very well in the class period. But so look back, and it's for part 1 only, not part 2. So look back at your part 1 and your part 2, sorry, your part 1, unit 1, and your part 1, unit 2, and see if you would like to retake one of those exams. If you do, in the OHS, you'll see an assignment, excuse me, a module, and it's, my instructions are very long. If you look at them, they're very long, but they're very specific on what you need to do in order to retake the test. Make sure you read it, because I don't want anybody to message me and ask how you can retake the test. The directions are there, so I don't have to tell everyone individually. Read the directions, follow them, and you'll be able to retake it. To basically give you a synopsis of it, you submit an assignment, and I have different questions, saying that you want to retake a test. I don't think I asked you which test to take yet. So after I get those submissions on Wednesday at noon, I lock the submission. So you have until noon on Wednesday to submit this first part of it. From that list, I will then email all of you a link to a Google form. That Google form is where you actually select the test that you want to take. That Google form, you have until Friday, I think Friday at noon. It could be Friday at 3, but I think it's Friday at noon, to submit that Google form to identify which test you want to retake. From that, I will then unlock the retake for you, and then you will have until this coming Sunday midnight to take that retake, and that's it. So that's the directions in a nutshell. All right, so most of you are done. So let's go ahead and talk about this one. All right, so all of you should have moved the constant to the other side and then also reorder. I ate some walnuts, and if you're not allergic to peanuts, walnuts, you get little grains in there in the back of my throat, making me choke. So I apologize for keep coughing in the mic. All right, so everyone should have got to this step. Maybe I saw some of you in chat said, "Oh, maybe you put a placeholder." Well, you don't. So if you just have the y squared by itself, there's no y term. You don't need a placeholder. There's nothing we need to do for this term here, so you don't want to force it. The only thing that we want to do here is factor anything out. Now, is there anything to GCF out of my x's? Yeah, there's not. So we're just going to leave a space. And this y squared, so if you notice, there's no y term. So do I need to factor this y squared further than what you see? Yeah, I don't. And maybe that was throwing you off, but remember the whole point of complete the square is to factor it. And y squared is y squared. There's nothing that you can do to this term to factor it anything less than a single term. So that this is just going to carry down pretty much all the way down until, well, we divide everything by whatever constant we get on this side. All right. What number did all of you get in this blank right here? It's like 100. Yeah, that sounds right. Yeah. And just like last problem, there's no GCF. Now I went ahead and I put a 1 here. You don't have to. And if I was a student, I wouldn't put the 1 there. I'm just showing it just because I found that a lot of you want to see it. Not a lot of you, but there are a few, so I do. But if I was a student doing this, I wouldn't show this 1 here. I would just show it just like you have here without the 1. But anyway. Okay, so we added 100 here. What number did you add on this side? Yeah, 100 also, because 1 times 100 is still 100, so that's nothing different. Now, with going from general to standard, for whatever reason, this is the part people will mess up on. They'll do everything right on the left side, and they'll put 100 here, or whatever it may be. And the mistake people do is they will forget to add whatever number is needed. And 1 times 100 is still 100. So that is the part that is missed. So we get 100 there, and 100 plus 125 gives us 225. And oops, everyone should have factored this trinomial into this binomial squared. Going over this part. Also, this is a minus 10 because remember, going back to here, this negative 20, remember, this is not 20, this is a negative 20. So don't forget that negative sign. Negative 20 divided by 2 is negative 10, and negative 10 squared is positive 100. That's why the 100 went here and nothing else. And then when it factors trinomial to this binomial, this number will always be whatever the number is when you divide it by 2 in this work over here. So this is a negative 10. And to verify, hopefully you do verify, negative 10 plus negative 10 is negative 20, and negative 10 times negative 10 is positive 100. So it's just kind of a quick math check to make sure that this number will give us the respective numbers up here. Okay, and then what did all of you do from this step? Yeah, divide by 225. And then we reduce. 1 over 225 is just, well, 1 over 225. And then 25, so looking at this one here, 25 over 225, what does this reduce down to? Yeah, 1 over 9. So that's how we get that 9 on the bottom there. Remember, never put the 1 in front. Never have the 1 coefficient, not needed. And then, of course, equals 1. Also, something to note, ellipses will always be a plus sign in between. So you're going to have your X term here plus your Y stuff term here equals 1. So plus sign, important. Just to kind of give you a little sneak peek later this week, when we do hyperbolas, hyperbolas look exactly like an ellipse equation. The only difference between an ellipse and a hyperbola equation is you will have a minus sign in between. That is the only difference. So hyperbolas are the equation exactly the same, with the only difference being this being a minus sign instead of a plus. Okay. Just to kind of give you a little preview of when we start hyperbolas. I think we're doing hyperbolas tomorrow. Day 1, that is. I forget. I haven't logged on since I logged off last week on Monday. All right. Anyway, yeah. So we're done here. All right. Who got this one correct? Who got this one correct? Good. And I'm guessing the ones that there's looks like 3 of you said you almost got it right. I'm guessing what threw you off and maybe what got you stuck was the fact that you only had x squared, or sorry, y squared right here. So maybe it kind of threw you for a loop. But I'm going to assume that talking about this, you realize that this problem was much easier than your brain told you it was based on this. But yeah. Anyway, nice job, everyone. Let's try another one. We got about 17 minutes left. All right, so everyone, let's do this one. This one is pretty straightforward. Everyone try this. Say 3 minutes, 3 or 4 minutes. You want more than 3 minutes? You want 4 minutes instead? We'll we'll do 4 minutes. 3.5. Okay, we'll do 4 just for fun. All right, 4 minutes, and then I will put the little polling at about 3-minute mark. And if actually, I'll do it now. When you finish this problem, just give me a green check, and then if everyone's done with this problem before the timer runs out, I will. One of you is already done. What? I think one of you wasn't paying attention. All right, let me. There's no way you can be done with this problem this fast. So let me restart the polling. Remember, when you are done with this problem, give me a green check. By the way, I can't see who's actually tabbed in, who's tabbed out, and the ones that are just constantly tabbed out. You're here, but you're actually not doing anything. I'm making that assumption. So, and again, I say this a lot, but guys, if you come to live sessions, make sure you're actually going to participate and work on problems. There is no reason to come to live session unless you're going to do that. Background noise, you hear me, but you're not actually listening. So you can always, if you're somebody who's easily distracted, you can always watch the recording later. You can download these off your Class Connect when you go to your old recordings. I also put all of my lessons on YouTube, so you are welcome to watch them on there. I will put the link in chat again for those that didn't get it the first time I brought this up. But yeah. Just waiting for 2 of you to finish. Hopefully those 2 people are here and working. All right. So we got 1 more. All right. Looks like everyone's finished. That's about 4 minutes roughly. All right. So let's just go to the final answer and see what we get. All right. Oops. All right. So your final answer for the x term, what is the binomial in the numerator? What did all we get for the binomial? So you got x plus 8 quantity squared. That sounds right. And what did all of you get for the denominator in your first term? 36. All right, I agree with that. What about the second term, the y stuff? What is that term in the numerator? Y minus 5 squared. And what is the denominator in that term? 4. Good. And of course, what does it equal? Equals 1. Very good. We got that one correct. Ooh, everyone got it right. Very nice. Very nice. Let me just show the work real quick for everyone that is here. Maybe you don't have to go through it together. So everyone was good about looking back to your work. What number did you add right here? 225. Very good. Yeah, very good. Yeah, that's the piece that would people like, everyone, if you miss this problem, it'd probably be right there. Maybe you put 25 there, but remember it's 9 times 25 is 225 is what we're actually adding to all sides. So that would be the part where people would mess up. Then from there, it's pretty simple, right? Good stuff. All right, I do have another one here. Let me skip it for right now because we got 8 minutes, and we do have to go back. We have to go from standard to general, which is kind of easy, but I still want to go over it. But go ahead and write this problem down, and you can work on it after class, and I will show the answer at the very end of class. But write this down for now for another example to do. X squared plus 3y squared minus 12x plus 24y minus 51 equals 0. And then work this problem out. So I'll come back to this page to show the answer at the end. All right, this example, now we want to go from standard to general. All right, what do you think we need to do that? What should we do first? So not necessarily make common denominators, not necessarily do that, but we do. So remember, we're going backwards. So we want to clear the fractions, right? So hopefully that kind of gives you a little push in the right direction. Multiply first by 64. Rachel, and we could do it that. We could absolutely do it that way. But there is a way we can do it in 1 step instead of 2. But Rachel, the way that you're saying is not wrong by any means. So Rachel says multiply by 64 and then by 9. Or kind of going along what she says is we can find our lowest common multiple. So 64 and 9. What is the lowest common multiple of 64 and 9? 576. And how did you get? Okay, so you got 576 by multiplying 64 times 9. Yeah, and in this case, oops. In this case, why can't I delete this? Okay, there we go. That is correct. But don't make the mistake of always assuming it's always going to be 64 times 9. Because in this case, yes, it is our lowest common multiple. But let me show you. So when I taught grade school, it was like my very first year. It was my student teaching way back when. I taught 8th grade and 7th grade. And when I taught this is how I did it. And your teacher in grade school may have done the same thing. Hopefully they did. But so what we're going to do is you're going to do a factor tree for 64 and 9. So let me go ahead and just do that on the screen real quick. So a factor tree of 64, we get 8 and 8, and then we get 4 and 2, and then 8 is 4 and 2 again, and then 2 and 2, and then 2 and 2. And then making a factor tree for 9 is super easy. It's just 3 and 3, right? But and maybe, you know, if you're someone that sees patterns and you see 64, you say, oh, 64 is the same thing as 2 to the 6th power, right? So we have basically 2 times 2 times 2 times 2 times 2 times 2, right? So next, when you do your lowest common multiple, what you're going to do is you are going to write all of your factors out. So for 64, hope I have enough room to do this. We are going to write all of the factors from left to right. So I write 2 6 times. So I'm going to have a 2, 1, 2, 3, 4, 5, and 6. So I just write all the factors left to right. Leave some space because, well, I didn't because I'm running out of room. But that's not 222,222. That's 2 times 2 times 2, 6 times, right? And then you're going to write the factors of 9. And remember, these are columns. So we have 6 columns of 2. The factors of 9 are 3 times 3. So we have to create new columns. So we have a 3 and a 3. So we're just lining stuff up, right? And then what you're going to do is you're going to drop. So once everything's lined up, you drop everything in that column. So we have a 2 here. We have this 2 drops, 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 this 3 drops, and this 3 drops. You are then, once you drop all of the columns, we're going to multiply them. Going back to 64, let's say this wasn't a 9. Let's say it was an 18. 18 is just 3 times 3 times 2. So I would put, if this was an 18, I would put a 2 in this column. I wouldn't create another column. If there's a blank, we have to fill it. So if that was 18, I would put a 2 right here. But then when I drop my columns, I would only drop a single 2, drop a single 2, drop a single 2, and so forth. But when you multiply all of these out, so when I do 2 times all those 2s times 3 times 3, we do get 76. So our lowest common multiple or lowest common denominator is equal to 576. Which so happens to be 64 times 9. This is just the work to show how we can easily find the LCM or LCD without guessing and checking. This is the math behind it. So hopefully that makes sense of how we get 576. Because if you just did this number times this number and 576 was not our LCD, then your final answer, it will be wrong. You'll have the numbers will be too big. which can be fixed. Like in the very end, if you can reduce every term by some factor, do it. And that's a way to get around it, if that makes any sense. But anyway, so we multiply every term by 576. And what that does is this reduces and it clears the fraction. This clears the fraction, and we get 1 times 576 is 576. And we get this. So 576 divided by 64 gives us 9. 576 divided by 9 gives us 64. And then that carries down. Next, we have to FOIL this. But if you know the multiplication rules, you don't have to show the steps, right? 4 plus 4 is 8, and then 4 times 4 is 16. Negative 3 plus negative 3 is negative 6. Negative 3 times negative 3 is positive 9. We're just going the other direction. So that is the trick that all of you should have learned, at least your freshman year, on foiling the binomial, the perfect square, to get down to here. Next, what we're going to do is we are going to distribute that 9 to everything in the X stuff. We distribute that 64 to everything in the Y stuff. So we're just going backwards, right? And then from here, what we're going to do is we are going to combine like terms. So this 144 and this 576 gets combined. We can also subtract 576 to both sides. I think I did that in this step. No, I didn't do that yet. So what I did, I just combined 144 and 576 to get 720. And then remember, in general form, we are going to reorder these terms. So we're going to have the x squared followed by the y squared, followed by your x term, followed by your y term, followed by your constant. The last step, which we could have done previously, is or even kind of really up here, we could have actually moved this to the other side. Doesn't really matter. You can leave it here until then. But from here, remember, it has to equal 0. So general form must equal 0. So you have to subtract 576 to both sides. And then we get the final answer. So again, general form, x squared, then y squared, then your x term, then your y term, then your constant, and then it must equal 0. So this is just going reverse of what we've been doing at the start of this today's lesson. All right, everyone follow? All right, we are 2 minutes over. Let me go ahead. So let me just show you the answer for this one. Do I have work for this one? I don't. So for this question here, please work this one out also by yourself, since we're out of time. But we want to go from standard to general. Your final answer for this one should look just like that: 9x squared plus y squared minus 90x plus 189 equals 0. So work this one out. See if you can get down to the same answer. Don't just skip these, guys. Remember, pre-calc, you do need to practice. So don't just think that you're good and you know it. You need to work these out. All right, going back to the one that we skipped. This one right here, from general to standard. Let me show that answer real quick. That answer should look like this: x minus 6 quantity squared all over 135 plus y plus 4 quantity squared all over 45 equals 1. So that is that answer. And then if you want more practice, I do have more. So I got these 6 examples here. And I give all of these in general form. And then the answers I have in standard form. But if you want practice from one to the other, just show the work. So if you want to practice going from standard to general, just start here and do the math, the steps, to see if you get back to the general form. If you want practice going from general to standard, start with this, do the math, to see if you can get down to the standard form. Here are the 6 extra practice if the modules are not enough for you. All right, Rachel, or not Rachel, Ryan, what page are you talking about? Last problem? Okay, let me go back to it. This one right here? Okay, good. And I do have one more thing to say after Ryan takes his little picture here. Let me know when you're good. All right. So I don't have time to work this one out with you. Let me quickly check the bell work for tomorrow to see if we do one like this. I don't. Okay. All right. So for this one, do not make the mistake of multiplying this problem by whatever 4 times 36 is. So do not multiply this entire thing by whatever 4 times 36. If you do it that way, it will be wrong. You have to find your lowest common denominator, or your lowest common multiple. Yeah, so Noah says you only multiply by 36. And to show that the factors, I'm just going to just do part of the work. So the factors of 4 are just 2 times 2, right? The factors of 36, well, I'm just going to do it up here. We get 6 times 6, and then we get 2 times 3 for both of them. I'm a fan of factor trees. I don't know if you all are too. But basically, we have 2 times 2 times 3 times 3. So for 36, we have 2 times 2. And if you notice, I put those 2's in our already created 2 column because there was space for them. And then we have 3 times 3. So, once we have them written out, we drop this 2, we drop this 2, we drop this 3, we drop this 3. And when you multiply these numbers out, we get 36. So that's why when you work on this problem, you are going to multiply everything by 36 and not whatever 36 times 4 is. So I got you started on this problem. And then when you finish the problem, you should get this. If you did make the mistake of multiplying this problem by whatever 36 times 4 is, the answer you get will have, like, it wouldn't necessarily be wrong. It's just not finished. You would have numbers that are basically a scaling factor. So basically, you would have whatever 36 times 4 is. So you would have 36x squared plus 4y squared minus, was it 360 plus whatever 4 times 189 is. And if you notice how every term can be reduced by some factor, in that case, if you did it that way, you would have to divide everything by 4 in the very end. It's not a lost cause. Like, if you made that mistake, you just have to recognize in the very end that if you can reduce every term by some factor, you need to. Doing it this way will allow us not to run into that problem. But anyway, all right, guys. Well, thanks for coming, and always, I hope you learned something. I will see you all tomorrow for day 2 of. Wait, no, sorry. This was day 3. So we'll be doing day 1 of hyperbolas. We are doing hyperbolas tomorrow. So I will see you all tomorrow.